Hello everyone, we are Hibikino-Musashi at home. We will introduce our techniques for our object recognition system. We use YOLO for the image recognition system. We need to train YOLO with a large number of pictures. First, we create a 3D model of objects. We use a smartphone application capable of 3D scanning called Clone. By using Clone, we can easily and quickly create 3D models of an object by shooting it on a dedicated marker. We use a turntable to create a 3D model, however, in this method, the bottom surface of the object could not be shot immediately. Thus, we shoot two flipped upside-down object 3D models of the same object to make a complete 3D model. Then, we combine 3D models of the object to backgrounds. For the backgrounds of the training images, we shoot background images, for example, a table, shelf, and other items. To adapt to various lighting conditions, we apply the automatic color equation algorithm to the generated training images. To incorporate the object images into the background images, we define several object locations on the background images. By placing the object images on the defined object locations, the training images for YOLO are generated autonomously. By this method, we can generate 400,000 training images from 15 class objects and 306 background images, for example. Annotation data for the training images are generated autonomously because object labels and positions are known. The accuracy of the YOLO is high, however, sometimes the robot can fail to recognize objects. This is an example of a misrecognition. Since the appearance of a rabbit toy and hedgehog toy is similar, it is difficult to distinguish them by using only the image. We are developing a soft hand with tactile sensors for the robot to distinguish similar objects. This sensor is made of silicon rubber, liquid metal, and coils printed on a circuit board. When a force is applied to the sensor, the liquid metal in the sensor will flow, and the inductance of the coil will change. We can measure the hardness of an object by observing the change in the inductance of the coil. Since this sensor is soft, the shape of the hand is flexibly changed to fit an object. Moreover, the robot can avoid damaging objects. We process the information from the sensor by a neural network. We use reservoir computing, kinds of recurrent neural networks to process time series information. Compared to a general neural network, the training cost of reservoir computing is low. We also develop a dedicated chip for reservoir computing. The computation speed of the chip is quite fast, and this chip consumes quite low energy, so it is suitable for the processor of the robot. By combining YOLO and soft hand, the accuracy of image recognition can be improved. In addition to the image from the camera and hardness from the soft hand, various information such as the roughness of the surface, the weight of the object can also be utilized to recognize an object. This information also can be processed in the reservoir chip quickly with low energy. We have introduced our object recognition system, the quick dataset generation system for the YOLO, and a highly efficient analyzing system of the hardness of the object by a soft hand and reservoir computing. We continue to research on this approach to realize smart robot which can help our daily lives in our home.